Hello everyone, I'm Nagraj, your Perf Test Coach. Concurrent users. To understand this concept, let us consider below example. Say we have a banking application where 1 million users have registered for online banking, but not all users might be logged in at the same time, right? Let us consider 50% of users have logged in, but not all logged in users might be doing some transactions, right? So let us consider only 30% users are logged in and also doing few transactions on our application. So to know with how many concurrent users we should do performance testing with, we should find out how many users might log into our application simultaneously and also will do some transactions. We should not consider idle users. I hope this concept is clear. Let us move on to the next topic. Bottleneck. So, what is a performance bottleneck? To understand this concept, let us consider this example. Say we have a 4-lane highway which goes from Melbourne to Sydney. Let us assume we will be having cars on all 4 lanes, and also we will assume that these cars are traveling at the same speed. So we can expect 4 cars to exit the highway every minute as they are traveling at the same speed. So in this case, the throughput of this highway is 4 cars per minute. Let us consider a different scenario. Say there is a road work going on this highway, and for few kilometers, the 4 lanes are merging to 2 lanes. Let's see what will be the throughput of this highway now. Let us assume we will be having cars on all 4 lanes, and also we will assume that these cars are traveling at the same speed. When these cars approach the roadwork spot, only 2 cars can pass through. So the traffic flow will slow down a bit and we can expect only 2 cars to exit every minute. So because of this roadwork, the throughput of this highway has dropped from 4 cars to 2 cars per minute. In this case, the roadwork is the bottleneck. Similarly, even in the software applications, if there are any performance issues in few components, these performance issues will bring down the overall throughput of application. That is why we call performance issues as bottlenecks. I hope this concept is clear. Let us move on to the next topic. Correlation. The process of capturing few parameters from the server response, like a session ID or access token, with an intention to use the values of these parameters in subsequent requests that we make to server is called correlation. For example, if you look at below snapshot of a JMeter, we are capturing the access token which is coming in the response of generate security token API. We are then saving this in token underscore param variable. And then we are passing value of token underscore param for authentication header. We cannot pass hard-coded token values here because these tokens have expiry and the server will reject our API request if we don't pass valid token. So we need to dynamically capture these tokens from the server response and then pass it in header. This concept is called correlation. I hope this concept is clear. Let us move on to the next topic. Parameterization. If you look at the URL of this view account details API, we are passing account ID for which we want to view the account details. If we are using same account ID here for all the API requests, then it will not be realistic scenario. That is why we need to pass unique account ID for every API request that we make to the server. And this concept is called parameterization. I hope this concept is clear. Let us move on to the next topic. Assertion. If you look at the response body of this update account details API, the status is coming as success. But when we are running performance testing, we will be making hundreds of API requests, and how can we make sure all the responses are having this status as success? To solve this problem, we need to add assertions on the server responses. This is how we add assertions in JMeter. Under parameters to test field, we can provide the text on which we should put assertion on, and when we run the load test, JMeter will check if the text is present in the API response or not, and if the text is not present, then the API request will be marked as failed. I hope this concept is clear. Let us move on to the next topic. Think time. To understand this concept, let us consider an online fund transfer transaction. In step 1, we click on fund transfer button. In step 2, we select either transfer between accounts option or pay someone option. We are humans, so we think for a while to take this decision. Even in step 3, the user might think for a few seconds to decide. Basically, we humans think before making any decisions. So if we want to simulate real lifelike scenario during our performance testing, we should even simulate this think time. So the load test script with think time will look something like below. I hope this concept is clear. Let us move on to the next topic. Pacing. Say user has just finished one fund transfer transaction. Before making another fund transfer transaction, he might wait for few seconds or even minutes. And then will make another fund transfer and again will wait for few seconds before making another transaction. So the time delay that we add in between transactions is called pacing. Think time versus pacing. If we add delays inside transaction, that is between each step, we call it think time. But in case if we add delays between two consecutive business transactions, then we call it pacing. I hope this concept is clear. Performance engineers use below terminologies a lot, but most of which are self-explanatory. Resource utilizations like CPU, memory, disk, and network utilizations, heap dumps, thread dumps, garbage collection, GC pause times, code profiling and tuning, SQL profiling and tuning. That's all for this lecture. I'm Nagraj, your perf test coach.